Hi everyone. We are back with section 1 for the distributive property, and once again, I'm pretty sure you know distributive property. If not, here's your chance to catch up. So we won't need to talk a ton. There are some new things we're throwing in though, so I do want to make sure that we mention those. But first of all, distributive property is when we multiply a term through the parentheses, and that's part of simplifying. Notice our objective is using the distributive property to evaluate and simplify. So when we're talking about simplify, we're going to talk about combining like terms, and we talked about terms previously. Please make sure you watch for negatives. Those seem to be the things that throw everybody off, if there's going to be anything. And distributive property looks like this if we're using variables. A multiplied by the sum of B and C is really AB plus AC. So we do that. So if I gave you something like -3 multiplied by the sum of x and 7, well, we would just go ahead. We're going to use the distributive property to simplify this. So -3 times x is -3x. -3 times a +7 is a -21. And hopefully everybody's got figured out that a negative and a subtraction are really the same thing. So -3x minus 21 is the same as saying -3x plus a -21. Nobody likes to put all those extra signs in there. It's just extra writing. So if we're going to use the distributive property, let's just do example number 2. Because I purposely wrote it weird, because you can distribute from the right or the left. We're so accustomed to seeing the problems written out like 1 and 3, where the 7 and the 8 are on the left-hand side. But number 2, we do have the grouping symbols, and we do have this 4 over here. So we're going to distribute the 4 and just work from left to right. So 4 times 6x squared would be 24x squared. Hopefully you know your times tables. That'll make these problems go quicker. If you don't, you got to go to your calculator and they won't go quite as fast. 4 times a -x is a negative, always the sign, the number, then the variable. And 4 times a -3 would give us a -12. So we just distributed from the right instead of the left. So let's talk about this distributive property with mental math. This is kind of a thing that throws people off, and it's just a little shortcut. So mental math, again, mental math means we're not using a calculator. So if you just go for number 4 to your calculator and type in 15 times 99, that's fabulous. However, you're not showing me that. The directions say to use the distributive property to rewrite each expression, then evaluate. Well, 99 is really close to what number that's super easy to work with? It's really close to 100, right? Wouldn't you say that 99 is the same as 100 minus 1? Right? That's simple. I'm going to bring that 15 straight down. Now we can use that and rewrite this. So 15 times 100 is 15 with 2 zeros after it, or 1500. 15 times a -1 is minus 15. You might have to rack your brain a little bit to come up with 1,485 when you do 1500 minus 15. What about if we look at 44 times 2.5? Well, we could also add. So instead of saying 2.5, we could say 2 plus another half. And then we'll bring our 44 straight down. So now when we do the distributive property, 44 times 2 is really easy, right? That's 88. What's half of 44? 44 times a half? That's 22, plus sign in between those guys. And now you might have to do a little bit more thinking to get, what is that, 110. So when I say that I want you to do mental math or rewrite the expression, that's what I'm talking about, either using subtraction or addition. If that number 4 was 15 times 100 and, times 101, we could do 100 plus 1 in those parentheses. For number 6, for the 49, I would probably do 50 minus 1, because 50 is a little bit easier to work with than a 49. So what is it close to, or how can you break it, like for that fraction 2.5? So like terms, so I mentioned we're going to have to simplify. Like terms are terms that contain the same variables and exponents. So exactly the same. So for example, something like 5x squared plus x plus 3x squared plus, I'm using lots of pluses here, 7x. I've got two sets of like terms, exactly the same variable with exactly the same exponent, right? I've got an x squared with a 5 and x squared with a 3. So our number out in front does not have to be the same. But the 5x squared and the 3x squared are exactly the same. So if we combine those, and those 5 and 3, by the way, are called coefficients, which I didn't talk about yet, but that would be an 8x squared. We keep the x squared the same, add the coefficients. And here I've got an x plus 7x. Hopefully you're sneaky enough to know if I've just got a plus x, there's one of them. So that would be plus 8x. Simplest form means that an expression has no like terms and no parentheses. So the parentheses, that's why we need to distribute. Like terms, that's why we're going to combine those guys. So no like terms and no parentheses. I'm not sure that I really need to do a example for that, do I? Simplest form is 8x squared plus 8x. The example from like terms with those four terms is not in simplest form. And the coefficient is always the number term in front of the variable. So if we've got, say, 8y plus y, first of all, are those guys like terms? They are, right? They both have just plain old y's. The coefficient for this first term is an 8. What's the coefficient for this second term if there's no number in front of the y? And so simplest form for that would be when we combine those two like terms. So simplest form would be 9y. So this is simplest form. And this is a coefficient. And this is a coefficient. And we combined those like terms. So let's do just number 9, I think, for this one. It says to rewrite using the distributive property and simplify. So notice I've got myself a set of parentheses. I'm going to need to use the distributive property. It's a little bit different than when we're doing order of operations because, you know, we've got variables in here in these expressions. And we're still dealing with expressions, not equations. So let's just go ahead and distribute. 3 times 4x would be a 12x. 3 times a negative x, so negative 3x. And now I'm going to ask you if there are like terms. Can I combine these two guys? 12x minus 3x. What is simplest form for this? 9x. You may be thinking to yourself, could I have just done the parentheses first? 4x minus x? You could have. It did say to use the distributive property. That's why I didn't even mention it until now. But you would get the same answer. You're just looking ahead a little bit. Holy moly. There's a lot here, huh? I think we're okay. Do you get the idea of this? If it's not possible, right? Not possible. Let's just do number 15, just to make sure. Just because of the negatives and all that stuff. So I've got a negative 3c and then parentheses 4 minus 6. I am going to use distributive property. Yes, you probably could combine like terms. You could take care of your parentheses first because they are. In number 12, we cannot take care of these parentheses first because it's a 2g minus 6. Here we technically could, but we're not going to. We're just going to distribute. So negative 3c times 4 is negative 12c. Watch your negatives. What's a negative 3c times a negative 6? Positive, right? Are these two guys like terms? No, they're not. The 12's got a C, the 18 has no variables, so this is our answer. We cannot do any more simplifying. That is in simplest form. There's no combining that we can do. And then we have more of these algebraics and going to, or taking the verbal and going to algebraic. But notice, simplify the expression and indicate your property. So we're just going back to the last section. I think we can skip that in the notes because we've been doing that and we'll be doing more of it. So lesson summary. Explain how to combine like terms. You could go back to an example, you could write your own example, or you could just explain it in words. And simplify this. -2 multiplied by the sum of 3x plus 6x. And that's it for lesson 1-4. Bring your questions to class with you, and we will talk next time.